Hello everyone, in today's lecture we will discuss a problem that is related to finding the geodesic equation and their solution. The problem is find the geodesics in R2 plane polar coordinates and its metric tensor is given by GAB that is equal to 100 r square, and here the value x1 that is equal to r and x2 is equal to theta, because we are talking about the plane polar coordinates in 2D. And the inverse of a metric tensor is given by GAB that is equal to 1001 by r square. We know that the metric tensor is in a diagonal form, so its inverse is simply the reciprocal of its diagonal entries. The Christoffel symbols for the above metric tensor are given by this one. I have already found out all these Christoffel symbols in my previous lectures, so you can check out that video. Now students, formula for finding geodesic equations are given by this one, like x double dot c that is plus the Christoffel symbol like gamma c a b, x dot a and x dot b, and x dot actually here represents the derivative, okay, and that is equal to 0. Here c is a free index and a and b are the dummy indices. Or you can also write the Christoffel symbols in this manner, okay. Now students, if we use the value c is equal to 1, you know that in the geodesic equations that is given by here c represents the free index, okay, and actually the value of c is equal to 1 2, because we are talking about the plane like in 2 dimensions, okay. So if I take the value, first of all we will take the value c is equal to 1 and then we will take its value c is equal to 2, okay, and geodesic equations are equal to the dimension. Like if we have 2 dimension or we are talking about plane, then we will get 2 equations, okay. Now if I substitute value 1, then I will get this one. Now we will substitute the values for a and b. We know that a and b are dummy indices, okay, and the variation of AB will be for 1 and 2, and we will write it in a sum over form. Like first of all we will substitute 1 1, then 1 2, then 2 1 and then 2 2, and these are actually the Christoffel symbols that we have found earlier. So if I will substitute their values, then only this one will retain and all the other Christoffel symbols are 0. We can also check out at like this one, only this value will retain and all the other values will vanish. Similarly, if we take the value c is equal to 2 in the geodesic equation that is given by this one, then we will get this value and only 1 2 and 2 1 retains and all the other values will vanish, okay. You can check out like something like this, okay. Now students, we know that here x1 actually represents r, because I have shown you earlier that x1 is equal to r, okay. Now r double dot plus the value of this Christoffel symbol 1 2 2 that is equal to minus r, and x2 is equal to theta, and theta appears twice, and so I have written over here x dot square and that is equal to 0, and let's say this is equation number 1. In a similar manner, if we substitute the value of x2 over here, like the value of x2 is equal to theta, then we will get theta double dot and plus 2 by r dot theta dot that is equal to 0, and this is equation number 2. Now students, if I multiply equation number 2 by r square, then we will get this equation. Now it is actually the formula of, and it is the simplest form of this one. Like if I take the derivative of r square theta dot, then I will get this equation. Now if I integrate this equation, then this dot will vanish, like this derivative will vanish, and we are left with this one, and that is the constant, say like constant of integration. Now we can also simplify it as like theta dot is equal to h by r square, and say this is equation number 3. Now if I use equation number 3 into 1, we will get, like if I use the value of theta dot in equation number 1, okay, then I will get h over r square whole square, and this is equal to this one, okay. There is some issue with the brightness, okay. and I will get this equation. Say this is equation number 4, because here 1 r will be cancelled out over here and we are left with 3 r's. Now here we have to make a substitution. We will take d by ds is equal to h by r square d by d theta, and we will take r is equal to 1 by u. Then we will get this one. Like for example, if I substitute over here r, like dr by ds, obviously if I take the derivative of r with respect to s, then I will get r dot. Okay, and r dot is equal to dr by ds, and the value of d by ds is actually h by r square d by d theta and r as it is. Now I will use the value r is equal to 1 by u, then that will be equal to this one. Means here we will get h u square d by d theta 1 by u, and if I take the derivative of 1 by u, then we will get this value. Okay, so r dot is equal to minus h du by d theta. Actually we try to find the value of r that we can substitute over here. Okay, so I have to take the derivative of r. So students, if I again take its derivative, then we will get this value, and upon using r is equal to 1 by u over here, we will get this term. Okay, and if we simplify it further, if we take h square u square as common, then we are left with this one, and after simplifying it further, we will get this value. Okay, now students, we know that the value of u is actually 1 by r, so I can also write it as 1 over capital R cos of theta minus theta naught, and r is equal to, means r will be get multiplied this side, and r, if I take r on this side, or by using cross multiplication, we will get this one, and this is actually the parallel equation for the straight line. Okay, and this is the solution for the geodesic equation in R2, that is in plane polar coordinates. Okay, this is all about this lecture. Thank you so much.